So hello folks, welcome to my channel. In this video I will be solving a CAT previous year question, and this is geometric question from CAT 1999. So let's start the video. First let us read the question. There is a square field with each side 500 meters long. It has a compound wall along its perimeter. Okay, at one of its corners, it will be corners. Okay, not commas. One of its corners, a triangular area of the field is to be cordoned off by erecting a straight line fence. The compound wall and the fence will form its borders. If the length of the fence is 100 meters, what is the maximum area in square meter that can be cordoned off? Okay, simple. See, before I start the solution, I will just tell you guys a few things. In geometry, there are no particular method. There can be multiple methods to solve a particular question. Okay, as long as your concept is okay, your method is okay, and you are arriving at the correct answer, you need not worry. Okay, so I might be solving using a different method, just someone else will be using a different method. Okay, so let me draw the square first. Okay, let me rename the square, like rename the points as A, B, C, D. Okay, so what we are supposed to do is basically we are cutting off an area. Okay, not exactly cutting off, we are cordoning an area in the shape of a triangle, and this is 90 degree obviously because ABCD is a square. Let me name this point as P and Q. Now let us assume, see, we have to maximize the area, right? Area of the triangle. The basic thing that comes to our mind is, what is the area of a triangle? Area of a triangle is area of triangle APQ, right? Basic thing, half into base into height. What is the base? Base is AP, height is AQ, or you can say that AP is the height, AQ is the base. Okay, doesn't matter. Now suppose this is, instead of writing AP every time, I will denote AP as X, AQ as Y, and this is given as 100 meters. So what I have to maximize is XY by 2. Okay, also there is a theorem called Pythagoras theorem. This is only applicable to right angle triangles. Using Pythagoras theorem, I can say that x square plus y square is equal to 100 whole square, which is your 10,000. Now, although this is a question of geometry, I will use a bit of algebra here. Okay, it's called AMGM inequality. Okay, AMGM inequality. Let me change the color. What does this AMGM inequality tells us? It tells that for positive real numbers, please mind the words positive, this is only applicable for positive real numbers. R stands for real number, and I am using the plus symbol to denote positive real numbers. Okay, for positive real numbers x and y, suppose x and y belongs to positive real numbers. Obviously in our case x and y are positive real numbers, right? Because lengths cannot be negative. So for positive real number, the AM, what is AM? AM is basically arithmetic mean, or you can say the average. How do you find the AM or the average? Sum and then divided by 2. It is greater than or equal to the GM, geometric mean. Multiply the two numbers, take the square. Now square both sides, what do we get? X plus y whole square. But like now, many people will think, why am I squaring, right? I am squaring because I need xy, I have to maximize xy. So if I square, it will become greater than or equal to 4xy. Okay, now I will use the a plus b whole square formula. It's a square plus b square. In our case, these are x and y, plus 2xy, right? and the 2xy, when it goes to the right hand side, it will become minus 2xy. So 2xy, what do you get here? Xy is less than or equal to x square plus y square by 2. Okay, now what does this equation inequality tells us? This is a very important conclusion, I would say, that we have derived here. This says that xy, the value of xy, or basically the product of x and y, will always be less than or equal to x square plus y square by 2. That means the maximum value of x and y, maximum value of xy will be equal to x square plus y square by 2. It can be less than x square plus y square by 2 also, right? But at max it can be only x square plus y square by 2. And why I am taking the maximum value? Because I have to maximize the area. And what is the area? Area is xy by 2. Okay, so what is x square plus y square? This 10,000 from Pythagoras theorem divided by 2 will give me the maximum value, which is 5,000. So what will be the area? Area will be use this again, use here xy, which is 5,000, because that is the maximum value of x and y, divided by 2, which will give you 2500 meters square. This is the maximum area that can be cordoned off. Okay, I hope this video was helpful, and just before I end the video, I would mention another method by which you can solve this using differentiation. Also you can solve this question, but I think differentiation is not in scope as per CAT or XAT syllabus. For engineers who are well versed with differentiation, they can try this as well. Like, I'll just give you the hint here. So area is equal to xy by 2, and x by 2 I'm keeping. I'm just expressing the area. Okay, expressing the area of the triangle in terms of a single variable. Okay, and what is y? Y is basically 10,000 minus x square under root. This is the area. Now just you have to differentiate the area with respect to x, and you will then equate to 0. Okay, and then you will get the value of x at which the area will be maximum. You can try this method as well, but I think this method will be a bit lengthier. That's why I went ahead with the AMGM inequality. Thank you guys.